What is the area of each part of the entire rectangle at right? What is the area of the whole figure? And write the area of the rectangle as a product and as a sum. So let me make this much larger so we can work with it. So as I go through here and I find the product for each of the individual pieces, the first piece that I'll look at is this box right here, and you can see up above I've got an x and a plus 3. And when I multiply x plus 3, I get 3x. So part of the area is 3 times x. The next part we'll look at is this. You can see above I've got an x and an x to the right, an x above and an x to the right. Doesn't look like a square, and this is just a generic area model, but when I do multiply x times x, right, I get x to the second power. The next part is I've got here, this is 8 it says, and off to the left I've got an x, and if I multiply x times 8, I get 8x. And then the final part that I have is up above there's an 8, and then way off on the side here there is a 3, and when I multiply 8 times 3, I get 8. 3 times 8, 8 times 3 is 24. So if I look at these parts, right, the area of all the parts is there's an x squared and then plus an 8x plus a 3x and plus a 24. I can combine two of these, right? 3x and 8x are like terms, so I can write them as one term. 3, 8, 9, 10, 11, it's 11x. So in simplified form, the area of the sum of all the parts would be x squared plus 8, 9, 10, 11x, that's 8x plus 3x, and then plus 24. Now, as a product of parts, if I look at the lengths of the dimensions, which are given on the outside, one of my dimensions is x plus 3, and the other dimension is x plus 8. So I'm multiplying x plus 3 times x plus 8, and when I do that, this is the product I get. I get x squared plus 11x plus 24. So question 91 says solve for the variable in each equation below, show your work, and check your solutions. So I'll try to be clear about what's the best practices for avoiding errors, what's the best practices for organized work. So let's start with A. We have 8 times x minus 22 equals negative 60. I will always rewrite the problem, even though it's right there on the same page. I will always write it down first. And I don't necessarily show that I'm doing each step, but in my mind I can tell you every single time what I'm doing from one line to the next. So for example, for this next line, I'm going to add 22 to both sides. Now I've got a negative 60 rather on the right hand side, and when I add 22 to both sides, this 22 that I have, negative 22 rather, on the left hand side is going to go away because negative 22 plus 22 is 0. So what I end up with is on my left hand side, because I'm adding 22, I have just plain old 8x, and on my right hand side I will have the number negative 38. So again, as I move from here, what am I doing? Adding 22 to both sides of the equation. The next thing I'm going to do is take both sides and divide by 8. So negative 38 divided by 8, x is equal to negative 38 over 8, and that's, honestly, that's a simple, honest answer. That's truthful, right? You might want to reduce it. Right? Both of those can clearly be divided by 2. In fact, 38 divided by 2 is 19, and 8 divided by 2 is 4. So I could write it as negative 19 fourths. I could also just choose to leave it in that form. And if I have to, I could, convert it and get a decimal or an improper fraction or something. But I happen to like, either one of those answers. The next thing I'm going to do is I'm going to do a check. When I'm doing a check, I like to put kind of a line down the middle of my page, because I'm just verifying what's on the left-hand side and the right-hand side. And you're not really allowed to move across the sides. You're just allowed to evaluate what the left and the right-hand side are. So on the left-hand side, I have 8 times x. Now, I know x simplifies to negative 19/4, but that's the same as negative 38/8. I think I like to leave it that way. Then I'm going to subtract 22 from that. The reason why I like writing it as negative 38/8 is if I do the multiplication, right, notice I get a giant 1 with an 8 in both the numerator and an 8 in the denominator. To show you more explicitly what I'm talking about, this becomes negative 38 times an 8 over a 1 times an 8. And since I have both a factor of 8 in the numerator and denominator, this is quite simply the number 38. So I have 38, and then I'm subtracting 22. And 38 minus 20, negative 38 minus 22 is exactly negative 60. And that's cause for celebration because we were told negative 60 is what it should be. So because the left-hand side and the right-hand side are in agreement, I know that this number, negative 38/8, which is equivalent to negative 19/4, is a solution that absolutely works. Our next problem, B, we have same thing. Let's write it down. So I've got 1/2 times x minus 37 and then equals negative 84. To each side I'm going to add 37, so I have negative 84 and I want to add 37 to that. So I now have 1/2 times x equals, now it's a negative 47. Now to get x alone, what I'm going to do is I'm going to multiply both sides of this equation by 2. And I think I'm going to show that step. So each side is getting a new factor of 2, and I'm writing it actually as 2 over 1. And when I multiply both sides by 2, you'll notice on the left-hand side, I end up with just a single factor of x. 2 times 1/2 is 1, so I have 1x. And over on the right-hand side, I have twice whatever negative 47 is. It turns out to be the number negative 94. Again, as I check this, right, I have a solid red line. You don't have to use red, but it's just my indication that I'm not adding things to both sides. What I'm just doing is evaluating what's on the left and what's on the right and checking that they're in agreement with each other. So I'll write what's the left-hand side. It was 1/2 times the value of x minus 37, and on the right-hand side I have negative 84. My value of x is negative 94, so I'm going to place that in these parentheses. And then when I take 1/2 of negative 94, I get exactly the number negative 47. And from negative 47, if I subtract another 37, I get the number negative 84. So because the number 94 makes both the left-hand side and the right-hand side equal to negative 84, it's indeed a solution. So my checked solution is x equals negative 84. So we are now on part C. C has 3 times x over 4, 3x over 4, and that equals 6/7. This is still a proportion, and as long as we have proportions, I'm going to use this shortcut. Again, I've said we're going to pivot at some point, and we'll talk about other ways of dealing with equations with fractions. Our textbook will call it fraction busters, but for now I'm just going to use this shortcut that the product of this diagonal, 4 times 6, is equal to the product of the other diagonal, 3x times 7. And writing that down immediately gives me 4 times 6 is 24, and then that equals 3x times 7, which would be 21x. And if I divide both sides by 21, right, 24 divided by 21 is what I get on the left-hand side. And on the right-hand side, 21x divided by 21 is x. So I believe x is 24 21st. 24 is the number 3 times 8, and 21 is 3 times 7. So there is a giant 1 there, and I can simplify this. So I'm going to write down that my answer, x, is 8/7. What I need to do now is check that answer. So we'll do that over here. And on the one side, we're going to write 3 times the value of x that we found, 8/7, and we're going to divide that by the number 4. And over on the right hand side, we're just trying to verify that it is the same as 6/7. So on the left hand side, I'm going to change this just a bit. I'm going to write this as 3/1 times 8/7. 8/7. 3 times 8 is the number 24, and 1 times 7 is 7. So I have 24/7 divided by 4. And if I wish to divide 24/7 by the number 4, I can take the reciprocal of that dividend, the divisor. I can multiply by it instead of dividing by 4. So in other words, this is equivalent to 24/7 times 1/4. I'm multiplying by 1/4. Well, when I do that, I can simplify this as 24/7 times 4. I intentionally didn't do the multiplication because I'm trying to pull out a giant 1. 24 is divisible by 4. In fact, it is 6 times 4 is 24 over 7 times 4. And you can see, because I have this giant 1, that the left-hand side is indeed 6/7. So since I have 6/7 on both the left and the right-hand side, I can see that 8/7 is indeed a solution. The last question on this page is, last part of this question, I've got 9 times a plus 15 equals 10 times a minus 7. If I subtract 9a from both sides, I have 15 equals a single a minus 7. And then I'm going to add 7 to both sides. 7 plus 15 is 22. So I have that a is equal to 22. And I can take that value and plug it back in. Again, now I really have a different left and right side. On the one side, I've got 9 times 22, and I'm going to add 15 to that. On the other side, I have 10 times 22, and I'm going to subtract 7 from that. 9 times 22 is 198, and then if I add 15 to that, I get 213. On the other side, 10 times 22 is 220, and then if I subtract 7 from that, I do indeed get 213. So because 22 makes both the left and the right hand side both equal to the number 213, it is indeed a solution to this equation. Remember, a solution to an equation is a value for the variable that makes the equation true. It makes this statement that the left and the right hand side are equal a reality. So for part D, the answer is A equals 22. Question A has the expression 3x squared times y, and we need to multiply that by 5x. As I look at the multiplication here, 3 times 5 is the number 15. And then I have an x squared times an additional factor of x, and then I'll write the y on. So when I multiply x squared times x, that's 1, 2, 3 factors of y. So that's a total of 3. So I'll write 15x cubed and then times y is my answer for A. For B, I have some negative exponents, and I'm going to neutralize those negative exponents by multiplying by x to the second and y to the second. And actually, I already have part of that done for me. If you look at it, do you see right here, this is x to the second times x to the negative second. So as far as the x's are concerned, that's x to the 0 power, which is equal to 1. So I could rewrite this as 1 times y cubed times y to the negative second power. So maybe I'll write it like this: y cubed times y squared. Y to the negative second. Yes, there's a shortcut. I don't want to discuss it yet. I'm going to neutralize this y to the negative second by multiplying by y to the second over y to the second. When I do that, I've just created the number 1 right here, right? Y to the negative second times y to the second is y to the 0 power. That equals 1. So I'm left with y cubed over y squared. And if I simplify this, there is a giant 1 right here. Both the numerator and denominator have a copy of y squared. The numerator has one extra copy of y left over, and I can see that this is a 1. So my final answer is just y. Now I want to just take a moment and look at a potential shortcut. I'm multiplying identical bases with different exponents. X squared times x to the negative second times y to the third times y to the negative second. When I multiply x squared times x to the negative second, that becomes x to the 0 power. Negative 2 plus 2 is 0, which is equivalent to the number 1. Now, if I do something similar with the y's, it turns out that y to the third times y to the negative second is y to the first, which is just y. So you can quickly see if you have identical bases, you can add the exponents, and I very quickly get to the answer that y is the simplest form for part B. On C, I'm going to probably go back to talking about taking that and neutralizing the negative exponent. So if I look at it, it's x cubed over x to the negative second. I'm going to take care of that x to the negative second by multiplying by x to the positive second in the denominator. And to not change the value, I do the same thing in my numerator. So what I have now in my numerator is x to the 5th power, and in my denominator I have x to the 0, which is 1. So this simplifies as simply x to the 5th power. The shortcut, which I'm reluctant to talk about, but I will, if you look at this division, x to the 3rd over x to the negative second, those both have bases of x. That's equivalent to x to the 3 minus negative 2. 3 minus negative 2 is 5, so this is x to the 5th power. Notice they're equivalent. Please only start deploying this when you understand what's happening. It's very easy to make mistakes. Understanding the fact that you can take an x to the negative second and multiply it by x to the positive second and get the number 1 really it lends itself to some more intuitive understanding of what's going on. For the final problem here, I'm going to write 3 copies of this factor. You can see I have 2x to the negative 1 to the 3rd power. So there's exactly 3 copies of that. So I have 2x to the negative 1 times 2x to the negative 1 times 2x to the negative 1. Well, if I look at that in terms of the 2's, I've got 2 times 2 times 2, which is 2 times 2 is 4 times 2 is 8. And then I have x to the negative 3rd power. They only want me to use positive exponents, so in order to deal with this negative exponent, I'm going to multiply it by x to the positive 3rd over x to the positive 3rd. In my numerator now I have 8 times x to the 0 power, which is equivalent to 8 times 1, or simply 8. And in my denominator I have 3 factors of x, or x to the negative 3rd power. Write and solve an equation to represent the given situation. Be sure to define your variable. So it's a very important practice of defining what your variable is. Let's read the problem. Samantha currently has $1,500 in the bank and is spending $35 per week. How many weeks will it take until her account is worth only $915? So the quantity we're looking for is how many weeks. So we're trying to figure out how many weeks she's spending money. So I'm going to say let x equal the number of weeks that Samantha is spending Well, if we start with $1,500, 1,500, and every single week that goes by we're spending 35, right? This expression represents how much money I still have in my banking account. And if you think about it, right, if X is the number of weeks, and then negative 35X is how much I've spent, or how much my account has decreased by. So after 0 weeks, my account has gone down by $0, so it's still at $1,500. After 1 week, it's gone down by $35. After 2 weeks, my account has decreased by $70. After 3 weeks, it goes down another $35, so it should be negative. It goes down by 105. So by multiplying this X times negative 35, I'm able to track how much is being deducted from my account. I want to know when this expression reaches $915. So this equation, right, 1,500x, or 1,500 minus 35x equals $915, will tell me exactly when X, her account, has reached the amount of $915. So I'm going to begin by, let's see, I don't like the negative 35x, but I guess I'll deal with it. I'm going to subtract 1,500 from both sides. So if I take 915 and I subtract 1,500, I get negative 585. So negative 35x is equal to negative $585. And if I divide both sides by negative 35, I get it's about 16. So in about 16 weeks, and actually it's 16.7, so a little bit more than 16 weeks. And it would happen sometime after the 16th week and before the 17th week. Her account would be worth about $915. Plot triangle ABC on the graph paper with vertices at 8, -4, 8, 1, and 2, 0. So let's start with A. A is over 8 and down 4. So A is over 8 and then down 4 units. So this is point A. B is over 8 and up 1 unit. That's B, 8, 1. I forgot what C was. C is over 2 and then up none. So here's C at 2, 0. So I have these 3 coordinates, and I'm going to go ahead and grab a ruler here and try to connect those points. So there's line A to B, and here is AC, and then finally I've got from A to B. So I have this triangle ABC. Okay, next it says, what is the area of this triangle? Oh, okay. So area is how many of these little square units it contains. You know, this shape, if I was to do the following, I could go, what would that be? It would be, I think, just down 1 unit. This, if I looked at this, I could turn this whole thing into a parallelogram, and it would effectively double the area. And I like to point this out, right? This parallelogram is equivalent to the area of a rectangle if I shifted this line with C up also, but I digress. The area of that parallelogram is just base times height, and the area of the triangle is 1/2 of that. So if you look at this triangle, this base from A to B, I'm going to call my base. It's 1, 2, 3, 4, 5 units long. So I've got 1, 2, 3, 4, 5 units long, and the height of it is a height has to be perpendicular to the base. So the height is 1, 2, 3, 4, 5, 6 units. So the area of this triangle is 1/2 times the length of this base 5 times the length of the height 6. 5 times 6 is 30, and 1/2 of 30 is 15. So the area of this is 15 units squared. And that's the answer to part A. Part B says triangle ABC is rotated about the origin 180 degrees to become triangle A prime, B prime, C prime. Name the coordinates of A prime, B prime, C prime. Well, what's nice is because because it is being rotated 180 degrees, it doesn't matter if it's clockwise or counterclockwise, because we would end up at the same point. But if I take this and I rotate this about this origin, right, 180 degrees, point C ends up landing right here at -2. And point B ends up being, it is on the -8 line, but B is -8 and -1. So this becomes where B goes. This is B prime. This is C prime. And A will go all the way around to -8 and then +4 now. So this is where A lands. Now, I've been visualizing these for a while. If this is kind of difficult for you, I really encourage you to have a piece of patty paper at home and to just kind of trace this, and once you've got it traced on the patty paper, to just mark a point at the center, hold your pencil there and rotate the patty paper around so you can see, start to learn, understand where these points go to when you do these rotations. So it does ask me to state the coordinates of A prime, B prime, C prime. So I could list them right here. I'll say that A prime is at -8, +4. B prime lands at -8, -1. And C prime ends up going to -2, 0. And if you look at those, right, there's kind of a relationship between where the points were and where they went. So for example, if you look at B, the original B was at 8, 1. Well, look at how that changed, right? B prime went to -8, -1. So the sign of both of those numbers changed. They just became the opposites. C was at +2, 0. Notice it went to -2 and then 0, right? The opposite of 0 is still 0, so it became the opposite. And A, probably the best evidence of this of all, A was at +8, -4, 8, -4, and notice where A ends up, right? A goes to -8 and +4. So it appears that if I want to do a 180 degree rotation about the origin, basically I'm just taking the opposite signs of my point. So if I have a point that's located at x, y, after doing a rotation about the origin, whatever x is, it's going to be the opposite of that, and whatever y is, it's going to be the opposite of that. So another illustrative point would be like if I had -3, 5, and I rotated it 180 degrees about the origin, I believe it goes to +3, -5. Again, I digress. This is the answer to, this was part A, and this is part B. Let's see what C says. C says, this time, triangle ABC is rotated 180 degrees about point C, okay, to form a triangle A double prime, B double prime, C double prime. Name just the coordinates of B. Okay, so let me do this with a different color. So this time, my rotation point is not the origin, but it's this point that I've marked in green. And when I do that, when I rotate it around, I believe that B is going to land, that's interesting. The pattern here was over 6 up 1, right? So the slope was over 6 up 1. So I think I'm going to just go, oh, that's interesting. 180 degrees is 2 90-degree rotations. So let's see, 1, 2, 3, 4, 5, 6, and then down 1. I'm just thinking to myself here, I believe that this is exactly where B triple prime goes. C is going to stay where it was, and A triple prime should be located right here. So just for my own personal, I want to draw that triangle. There we go. So again, I've done a 180 degree rotation, this time about point C. Right, and then finally it says triangle ABC is rotated 90 degrees clockwise about the origin to form A prime, B prime, C prime. Oh, I didn't write down the answer for C. C, it asks what's the coordinates of B double prime. B double prime is at, looks like it's at -4, comma, -1. And now D. It says if triangle ABC is rotated 90 degrees clockwise about the origin to form triangle A triple prime, B triple prime, C triple prime, what are the coordinates of A triple prime? So this time I'm going 90 degrees about the origin. Let's think about this. So I am going about the origin. I'll use blue this time, so this is where I'm rotating. And I know that when I rotate, I know a slope triangle, the rise and the run switch places, and the signs change on one of the variables. So I'm pretty sure it said clockwise, right? Clockwise. So the clock rotates this way. So I believe point D is going to land right here. Right? If you look at it, before my slope triangle was rise of 0, run of 2. Now it's a rise of -2 and a run of 0. So I think those are opposite reciprocal slopes. If I look at my line from B to B prime before, that was over 8 up 1. Now I think I'm going to go down 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then I think I'm going to go back 1. So I believe this is the point B triple prime. So I think you can see what I'm doing. I'm looking at the slope, and I'm doing the opposite reciprocals to get where these points are going. So the final one, let's look at this. A was over 8, down 4. So instead of going over 8, down 4, I'm going to go down 8 and then to the left 4. So down 8 and then 1, 2, 3, and 4. So I'm totally seeing, this. Did I go far enough? 1, 2, 3, 4, 5, yeah, and 1, 2, 3, 4, 5, 6. Yeah, so this is the triangle that results after I rotate this thing 180 degrees about the origin. My problem with this ruler is that it's very slippery on glass, and it's the glass screen on the surface is hard to keep the ruler in place. Alright, so if I take the entire plane and I rotate it 90 degrees clockwise, this is the shape I end up with. They did want me to identify the coordinate of A triple prime, and A triple prime is here, and it's going to -4, -9. So I'll put that answer here. It's going to go to -4, comma, -9. Okay, final question of the evening. Whew, this has been a long homework assignment. It says draw the line y equals 3/4 x on graph paper. So if I consider that line just a moment before I do it, it's y equals 3/4 x plus nothing, 0, nada. That means that my y-intercept is 0, and I'm going right through the origin. So it's pretty simple to graph that, right? I'm going to start at the origin. I guess I'll use green for this. So here's where I begin, and I'm going to go up 3 units, 1, 2, 3, and then over 1, 2, 3, and 4. Again, up 3, 1, 2, 3 units, and then over 1, 2, 3, and 4. And then up, is it up 3 over 4 or up? Yeah, up 3 over 4. Keep going. Up 1, 2, 3, and then over 1, 2, 3, 4. And then I can also go down 3 and back 4, and then down 3 and back 4. So I can clearly see the line there. Let me grab my ruler and try and hold that in place while I draw the line that goes through there. Not successful yet. There was definitely no line showing up on the paper. Here, let's try that one more time. No? There's blue ink. I want green ink. There it is. So just hold this in place. I need to get a ruler that is not plastic. It's just too slippery on the glass screen. Okay, so here is the line. Up 3/4 is my slope pattern, and it has a y-intercept of 0. A says draw a slope triangle. Okay, so there's a lot of different ones I could pick, and I don't think anyone's right or wrong, but this is a slope triangle right here, and I'm just going to go up the 3 units, and I'll do that in blue, and then from there I'm going to run 4 units to the right. So you can see that is a slope triangle for this particular line, up 3/4. And what I'm going to do now is I'm going to take this slope triangle, and in part B it says rotate your slope triangle 90 degrees about the origin to get a new slope triangle. So it's just the slope triangle I'm focusing on, I guess, and I'm going to rotate the I'm rotating actually the entire plane, but it said just rotate the slope triangle on it. So I'm going this direction and this direction, and it didn't tell me if I was going clockwise or counterclockwise, so I'm going to go counterclockwise about the origin. And when I do that, actually that last problem actually was difficult, but it gave me some insight here. If I rotate about the origin 90 degrees, I know that this point right here, if I think about this one at 4, 3, x is 4, y is 3, if I was to go back 3 and up 4, you can see that I've switched the order. It was 4, 3, now I'm going back 3 up 4, and I made one of them negative. And that point is the one that I believe corresponds exactly to the one that I circled in black on my original slope triangle. In fact, I'll do that again if I for this point, right? So that's over 8 and then up 6. So what I'm going to do is I'm going to go back 6 and then up 8. So back 6, this line, and then up 8 right here. And this is the other, part of the I guess it's the hypotenuse of this slope triangle, right? This right here. Now, I don't have the slope triangle, but let me add it, and I'll use the original colors. Originally, this was blue, right? Over there, it was the rise in the other one. And then the red, it was the run, and now it's the rise over here. So if you look at what happens by rotating this around, we see this again. The slope has changed, right? It's the slope triangle was up 3/4. Now this new one's down 4/3. So this new slope, that's I guess my answer to part B. Originally this had a slope of, and I should write this down. This one had a slope of very clearly up 3/4 units. Now this new slope triangle is down 4 and then to the right 3 units. And you can see right here I would go down 4 units and then I go to the right 3 units. So clearly we can see that if lines are perpendicular to each other, because I rotated through 90 degrees, I'm getting slopes that are opposite in sign, right? One was negative, one was positive, and they are reciprocals. One was 3/4, the other one is -4/3. And then finally it says, and by the way, I could I don't know, they didn't ask me to do it, but I think I would feel more complete if I went ahead and sketched this line. So if I drew this line in here, you can see that these two green lines are forming right angles with each other. It's just wonderful that we can do that. It's great technology. Then it says write the equation of a line that is perpendicular to a line that has a slope of 4/3. Okay. Well, if it had a slope of 4/3, that's up 4/3. A line perpendicular to it, right? The perpendicular line would have a slope that's opposite in sign, so it would be negative, and then my rise and run are switching places, so -3, 4. So this would be down 3 and then over 4 units. So that is the slope of a line that's perpendicular to the line y equals 4/3. That's it. Have a nice evening.